conductivity contrast. So this is really important. So again, as I mentioned, so we're looking for conductors in ear. That's the whole point of ear. And small change from, we had a 10 ohm conductor, which we saw in the signal in the previous model. It's the same model, just with an 80 ohm conductor. So in the grand scheme of things, that's not a big jump, in the range of resistivities. Empty can't see it between a contrast anymore because resistors for empty look the same. It needs a good contrast between a conductor and a resistor background. Okay, so this is where the forward modeling, the guys for the field school forward modeling comes into to see what sort of conductivity can we see with the systems we'll be using. So again, this is just a geophysical concept. If you don't have contrast, nothing's going to show up. But in terms of EM, conductors are the key. It's, say 5 to 10 ohms, or something that's very like the contrast. So you have like a 10,000 ohm background with a 100 ohm object in it. So that you have to keep in mind that we're looking for conductors. Okay. So if you don't have a significant contrast, you won't have any signal. So if you try and model this, will be the same as that model I showed you with the depths. There'll be nothing in the model itself. Okay. So this is again when you model it. There's nothing there. So this purple and blue is just because it's a log scale. So that's all really the same value. Okay. This is something that's really important when we go out to the field. So your noise sources for MT are any sources producing current in the ground, so current leakages, so things like generators, power lines, railway lines are the worst. Power lines are okay because we know their frequencies, so you can take out that. So they have like 50 hertz and they have multiples at different frequencies, but you can generally pull them out, but they do saturate your signal. So ideally, you don't want to be too close to a power line. For example, the project I'm working at the moment, these orange and red are the high voltage lines, but we have this black is railway lines. And these blue dots are the Samtec stations, so that's part of that large MT experiment across South Africa. So they were done alongside these railway lines. So I'll show you what it does to the data. So you see the high frequency data is okay, but remember I told you that MT is smooth. You don't want any big jumps or anything that's like 45-degree dipping is not, it's basically meaning that an external signal is amplifying that electric field and it's pulling the resistance down. Okay, but you see what the DC line did. So you can see initially at the near surface quite 1D your lithology. So that's what's showing the overburdens and then the sediments, and then we get into 2D structures. So that could be contacts, faults, anything like that. So just looking at your data, you can really tell a lot about what's underneath you before you even process or convert the data. That's what's nice about the MT data. So I think the red is the TE and the blue is the TM again. But once you start getting to low frequency data, this is where the DC railway lines, that's when they start interfering. It just blows out. So all this data you just get rid of. You can't do anything with this data. And the problem is if you're under a power line, you can see, so another trick when processing, when we get into this, I like to use the phase to process, because the phase really doesn't fluctuate. It will have very smooth motions in the phase. And things like this, when it starts bouncing, you can really see that that's noise. So you can get, when you take the phase out, it will usually automatically take the resistivity out as well. So in processing, you can actually just focus on the phase and use that as a guide to remove noisy data. But in terms of the DC lines, they destroy most of the low frequency data. And that's why on mantle scale experiments, if there's DC lines nearby, it's almost impossible to do because of this. And because of the rock that's quite resistive in this area, you need to be like 20 k's away from the lines. And away in South Africa, you're going to be away 20 kilometers away from a DC line and then some sort of power line that's interfering. So this is things you have to consider when doing MT with your noise sources. Something interesting, the worst power source, the sort of noise introducing system is agricultural equipment. You know, the crops, the irrigation systems, you know those ring systems, make those rings, those are the worst. They leak so much current. They're worse than these railway lines. If you're near one of these crop circles and they are irrigated, you're not going to get any signal. It's just going to be sporadic. Because they've got no control of the frequency, so it's just dumping current into the ground. Okay, so that's something to keep in mind when on these farms, like if they're irrigating something.